Hello, sir. Good morning. Singh, sir. Good morning. Rashmi, madam.
Yes, sir.
Okay. Am I audible, na? Okay.
Yes, sir. You are audible.
It is clear, na? Okay.
लेक्चर सुरू झालं नाही काहीतरी आहे
मॅडम काही बोलतील थोडं मॅडम.
Yes, sir.
मला दिसत नाही आलं chemistry guest lecture on concept in नाही का ते पाठवलं होतं सरांनी रजिस्ट्रेशन
Sir, can I start?
Singh, sir. Without sir, I have joined. But, 1 minute. Hello, hello, Vijendra sir.
Yes.
Hello. Hello, Singh sir.
सर झाले का जॉईन झाले सर?
जॉईन झाले आहे फक्त त्यांचा आवाज येते का नाही बघत आहे.
बर.
हॅलो सिंग सर. Sir, Singh sir, you are not audible. Hello.
सर सिंह सर आपका आवाज नहीं आ रहा है.
Hello.
Yes, sir, you are audible now.
Now you are audible, sir.
Hello, hello, Dr. Singh sir. Hello,
हे बघा सर.
hello, hello, Singh sir. रश्मि मैडम, सिंह सर ऑडिबल है क्या?
No, sir.
रश्मि मैडम, हेलो,
Pallavi Chavan, you mute yourself.
हेलो, सिंह सर.
सर त्यांना फोन करा ना एकदा.
हो, ठीक आहे.
यहाँ से आवाज बढ़ेंगे सर.
ये बंद ही है. ये बंद है.
ये तो देखो आपने पूरा जीरो कर दिया था.
जॉईंट आहेत मॅडम. हेलो, नॉट ऑडिबल. सिंह सर. हाँ सर, यू हैव जॉइंट बट यू वो जो है ना वो टेस्ट करिए सर अपना, क्या बोलते हैं उसको, क्या बोलते हैं, माइक वो नहीं क्या ऑडिबल वो आता है ना, फिर से ज्वाइन कर लें तो फिर आप, है ना. हाँ सुरेश. हो मी थोडा फोन करतो तुला. एक तो गेस्ट लेक्चर आहे सरांचा, ते स्टार्ट झालं जस्ट आता होतच आहे 1 मिनिटात. मी थोड्या वेळात करतो, ठीक आहे ना. हा. हेलो. हाँ सर। अच्छा, ऑडियो नहीं देखा हूँ आपने। ज्वाइन विथ ऑडियो कौन सर? ज्वाइन विथ ऑडियो। हाँ हाँ, बस हो जाता है फिर। आप वॉल्यूम जो होगे ना बढ़ा दो ना उसको। वॉल्यूम कभी कभी ये होता है, प्लस देखो, वॉल्यूम बढ़ा दो।
प्लस
प्लस वाला है ऊपर, वॉल्यूम है। कोई और है नहीं वहां पर?
सर भी है मेरे साथ, एक हम कर रहे हैं सर, कोशिश कर रहे हैं।
अच्छा चलो ठीक है, ठीक है। हाँ मैं रुकता हूँ ना सर, कोई कोई बात नहीं है। ठीक ठीक ठीक।
हेलो।
हाँ हाँ सर, आप बात करेंगे तो हाँ। अब नहीं, अभी नहीं आई। नहीं, स्पीकर चेक कर लीजिए, वॉल्यूम चेक का है ना, स्पीकर ऑडियो वाला है ना।
हेलो सर, अब आ रही है
अभी
आवाज? आई
हेलो, यस यस यस, आवाज आ रही है।
ओके ओके सर, ओके ओके।
हेलो सिंह सर। हेलो।
हाँ यस, am I audible?
यस यस यस, नाउ इज ओके।
Sorry for interrupting and
सर कैन वी स्टार्ट?
हाँ yes we
मैडम
can start.
रश्मि
Okay.
Sorry sir, sorry.
Yes, sir. A warm welcome and a hearty good morning to all gathered here. This is Rashmi Dubey on behalf of Department of Chemistry. Lead all of you through today's session. But firstly, I pay my homage to late Shri Govindraoji Vanzari sir, founder president of Amar Seva Mandal. I also pay my heartfelt gratitude to Honorable Dr. Suhasini Vanzari ma'am, President Amar Seva Mandal, Honorable Advocate Abhijit Vanzari sir, MLC and Secretary Amar Seva Mandal, and Dr. Smita Vanzari ma'am, Treasurer Amar Seva Mandal, for their continuous support and guidance. I heartily welcome our today's guest, Dr. Vijendra Singh sir, Assistant Professor, Department of Chemistry, School of Liberal and Arts Science, Modi University of Science and Technology, Rajasthan. I also welcome Dr. S.M. Garegone, Head of Chemistry Department, Kamla Nehru Mahavidyalaya, Nagpur. Dr. W.B. Gurnole sir, Dr. M.S. Wag ma'am, and all the faculty members and my dear students who joined today's session, I welcome all of you for this. Now, as we know, a lecture is an occasion when you nerve one to benefit other. And as we know, our today's guest, Dr. Vijendra Singh sir, going to talk on concept of chemical kinetics. But before starting session, it's my pleasure to introduce him. Dr. Singh did PhD in chemistry from Government Madhav Science PG College, Ujjain in 2012. Dr. Singh has joined Department of Chemistry, ISR IPS Academy, Indore in 2013. Recently, he is working with Department of Chemistry, School of Liberal Arts and Science, Modi University of Science and Technology, Rajasthan. He has 9 years of teaching and research experience in the field of chemical science. He has published various research articles and referred national and international journals and books with national and international publishers. He is member of different academic bodies like American Chemical Society, Royal Society of Chemistry, and Association of Chemistry Teachers. He received research grant from Madhya Pradesh Council of Science and Technology in 2019, and he has member of editorial board of various national and international journals and publishers. He has done international short-term course and FDPs from various organizations and countries. And he has also worked as ambassador for Rio Plus 25 UN Water Decade Program announced by UNESCO and International Year of Plant Health to 2020. He has won Best Paper Presentation and Best Research Award also. And presently, he is working on synthesis of various nanomaterials wastewater treatment technologies, and green chemistry. So I request Dr. Singh to start his session now. It's over to you, sir, now. Sir, your voice is not coming.
Hello, am I audible?
Yes, sir.
Hello.
Yes, sir. Now you're audible.
Okay, yes. Thank you very much for nice introduction. Okay, and just without wasting up time, okay, just I am going to start my presentation, and it is related to concept of chemistry and concept of chemical kinetics. Now, just I am going to share my screen. Yes, is it visible? So
Yes,
screen
sir.
is visible. Okay,
Yes, sir.
yes. And thank you. Yes, Dr. Vijayendra Singh. And what about the chemical kinetics? But before the discussion of chemical kinetics, just I am going to discuss about the some chemical reactions, okay, which are takes place in our daily life. And then I will discuss about the chemical kinetics. And just you can see here the rusting of iron. This is the reaction, photosynthesis, cooking, anaerobic respiration, combustion. Okay, these are the some chemical reactions, okay, which are takes place in daily life, our body, in the environment, and even in our body also. Like so many reactions. Okay, now like anaerobic oxidation or anaerobic respiration. And what about the outline of the chemical kinetics, because today the topic is concept of chemical kinetics, okay, in which I will discuss some points like reaction rates, how we can measure the reaction rate law. This is the another heading. Okay, how the rate depend on amount of reactant, means I will discuss about the how the rate is depends on the amount of reactants, on that is the concentration of the reactant. Then discuss about the integrated rate law, then discuss about the half-life time of the reaction, then Arrhenius equation, mechanism of the reaction, theories of chemical kinetics. Yes, am I audible?
49.
Yes, sir.
Collision theory and the transition state theory. Then discuss about the catalysis, that is the homogeneous and heterogeneous catalysis. Now, here, before the discussion of chemical kinetics, just giving the simple pure, that is, it was given by J. von Liebig, and chemistry should not only be a science and professional, but also an art. Okay, it is art also. It is not a science. Okay, science to hai, iske saath kya hai? It is art, and it is yes, and it is only as an artist that the personality of a scientist can survive. It was given by the J. von Liebig. And now, what is chemical kinetics? Okay, and who were introduced the chemical kinetics, and the scientists, just you can see here the name of the scientist, English chemist Augustus George Vernon Harcourt. In 1934 to 1999, he gave the concept, first he gave the concept of chemical kinetics. And the first quantitative study in chemical kinetics has been done by German scientist Ludwig Friedrich Wilhelm in 1812 to 1864. Okay, in 1850, who used polarimetry to investigate the acid catalyzed conversion of sucrose. Okay, you know about the polarimetry. This is the instrument by which we can find out, we can calculate the angle of rotation. Okay, and the first reaction was observed. Okay, conversion of sucrose. Now, just this is the chemical kinetics, and what is the concept of chemical kinetics. And now, what is chemical kinetics? And just you can see here how fast does a reaction proceed. That is the speed of the reaction in chemical kinetics. Okay, we can determine the speed of the reaction, and another term is thermodynamics. And kinetics say how fast does a reaction proceed, and the thermodynamics say does a reaction takes place. Okay, and both are related to each other. Okay, and what about the speed of the reaction? In physics, the speed, that is the velocity, that is the speed. But in chemistry, the reaction rate or rate of reaction is indicated by the rate. Okay, am I audible? If not audible, please confirm me. Okay, and again I will discuss about some important factors which affect the rate of reaction actually, and some factors which can affect the rate of reaction: reactant concentration, temperature, action of catalyst, surface area, pressure of gas and gaseous reactants and products. And now, again, what is the meaning of kinetics actually? And just I have discussed the studies the rate at which a chemical process occurs. It means kinetics, it is the speed, okay, or the rate by which it gives the information about the completion of the reaction actually. If suppose A is the consider A is the reactant and it will take 10 minutes to convert into the product, it means the speed of the reaction, rate of the reaction will be 10 minutes. Okay, but kinetics is also related to reaction mechanism and how the steps, okay, will take, okay, how the steps in the chemical reactions. Okay, it means if the reactant converted into the product, it will cross the some steps, okay, through the reaction. It is called reaction mechanism. Okay, so it means the overall definition of chemical kinetics, it means it is the branch of physical chemistry which deals the study of rate of reaction and their mechanism. This is the definition of chemical kinetics. Okay, kinetics means it is related to rate of the reaction and also it is related to reaction mechanism or mechanism of the reaction. That is exactly how the reaction occurs. It means what is the meaning of this? Exactly how the reaction occurs. That is the how many steps of the reactant taken to convert into the product. Hello. Hello, am I audible? Clearly, I am audible or not? Please.
Yes, sir, you're audible.
Yes. Madam, अगर audible नहीं हो तो आप बताना मुझे.
Yes, yes, definitely.
Okay, now. Yes. Another, what is just I have discussed about the rate. Okay, now again discuss about the kinetic reactions. Okay, on the basis of reaction rate. Rate means what is the definition of rate? It is the time. Okay, or change in concentration of reactant or product in a unit time. This is the rate of reaction. This is the definition of rate of reaction, and on the basis of the reaction rate, the reactions can be classified into 3 categories. Okay, the first is very fast reaction. Okay, very fast, that is you cannot determine the rate of reaction. This type of reaction completed into 10 to the power minus 17 to 10 to the power minus 16 second. That is the very fast reaction, and in chemical kinetics we cannot determine the rate of reaction of this type of reaction actually. Just you can see the example here, precipitation of silver chloride. Okay, it means when silver nitrate and sodium chloride are mixed together, we get silver chloride. Okay, in which the reaction is very fast and reaction is completed into 10 to the power minus 17 to 10 to the power minus 16 second. And another example is neutralization of an acid. Just you can see the chemical reaction here, and HCl plus NaOH, and when it mixed together, we get NaCl. Okay, this is the example of the very fast reaction. It means very fast means it completed into the very less time. Okay, in a few seconds it will complete it. Okay, now very slow reaction. Very slow reaction, it means the reaction between just you can see the example here. Very slow means, just I can give the example of the rusting of iron. It is very slow reaction. Okay, rusting of iron, that is the oxidation of metal, oxidation of iron. Okay, it will take the month, it will take the years, it will take the so many months. Okay, hello. Okay, and another example is reaction between hydrogen and oxygen at room temperature. The reaction between the of atmospheric hydrogen sulfide and basic lead acetate, and formation of HCl in dark condition. These are the examples, some examples of the very slow reactions. And another type on the basis of reaction rate is third category of the reaction is moderate speed or moderate reactions. Okay, and moderate reaction, you can see the example on the screen: hydrolysis of ester, decomposition of nitrogen pentoxide, decomposition of hydrogen peroxide. These are the examples. Okay, and it is related to moderate speed. Now, and question is that which type of reaction can be considered in the chemical kinetics? Okay, who will give the answer? Students, am I audible? Who will give the answer? In chemical kinetics, which type of reaction can be studied? कौन बताएगा आंसर? हाँ, yes, कौन बोल रहा? What's your name? You're not audible actually clear. Okay, please tell me. In chemical kinetics, which type of reaction can be considered? Yes, you are right. You are not audible clearly, but your answer, I just received your answer, and you are right. Moderate reaction, moderate speed. Okay, it means in chemical kinetics, okay, generally the reactions which are occur or the rate of reaction can be determined. Okay, the reaction is the moderate speed reaction. That is the hydrolysis of ester, that is the decomposition of nitrogen pentoxide. Okay, these are the reaction. Okay, and this type of reaction can be studied in the chemical kinetics. Now, another, just you can see reaction rate, and this is the graph, okay, which is taken from the sources, and it is graph is plotted between the time and concentration. And here you can see A is the reactant, okay, and it take the actually it forms product B. Okay, and just you can see here concentration. This graph is plotted between the concentration and time, and with the time, the concentration of product, the concentration of reactant is decreases, and the concentration of product is increases. Hello, आपको ये please tell me the cursor is visible na, on the screen? Okay, हाँ. So, have you understood? Yes, concentration and time. Okay, and it means the A is the reactant, and the concentration of reactant is decreases with the time, and the concentration of product is increases with the time. That is the change in concentration of reactant or product. Yes, now another example of the reaction rate. Just you can see here, and reaction rate. Okay, in the container, the 1 mole A molecule of the reactant is taken. Okay, and the concentration is 1 mole per liter. Okay, A is the reactant, and the time is 0 second. Okay, but with the time, the concentration of reactant is 0.54 mole on, and the concentration of product is 0.46 mole. Okay, B is the product. Okay, if the reaction is not started, okay, at the zero time or 0 second, there is no product here. Okay, only the particle is the A, that is the reactant particle or particles of the reactant. But in the second container, just you can see the reaction is started, and after 20 seconds, the product is 0.54 mole. Okay, and the reactant is 0.54 mole, and the product is 0.46 mole per liter. It means consumption is here, or the formation of the product is started, and but after 40 seconds, in the third container, you can see the remaining concentration of reactant is 0.30 mole per liter, and the formation of product, that is the concentration of product, is 0.70 mole per liter. Okay, now, and how we can represent, okay, how we can represent the concentration of the reactant or concentration of the product. And just you can see here, this is the notation for stoichiometry, in which you can see that the square bracket is represent the concentration of the reactant. Okay, that is the in square bracket. Okay, just you can see it is the concentration of reactant, and B is the concentration of the product. Now, yes, I have discussed this, and now what Hello, am I audible? Hello, students. Just you can see the reaction. Consider A and the product is B, okay, and the speed at which the reactant disappear and the speed at which the product appear. And I have already defined the rate of reaction, okay, in change in concentration per unit time. And in the instantaneous rate, another rate is instantaneous, which takes place in very less time, okay. And if we represent the instantaneous rate, we are going to represent, or we want to represent the instantaneous rate, that is, we can represent here del concentration of A upon del T with time. And the differentiate equation of these is D concentration of A upon D T. Okay. And most common, we can write here mole per second. Okay. And where mole per liter, mole means it is related to molarity. And it means we indicate the rate is mole per liter, or the concentration of the solution. Concentration of the solution will be the unit of the concentration of the solution will be the mole per liter. और अगर यहाँ पर मैं स्पीड की बात करूं तो it is related to second, or it may be represent in the time, it may be represent in the hours. Okay, it is depends on the question actually. And what about the now how we can represent the reactant and product? Okay, now as you can see this relation here, okay, in which the rate, but you can see here the sign is minus, okay, because what is the reason why the sign of A is the minus? Okay, who will speak? Student?
Because A is a reactant, that's why.
Okay, A is the reactant and the concentration of reactant is decreases with the time. Because of this reason, okay, the significance of minus is here, okay, and the minus represent the decrease in concentration of the reactant. Hello, yes, please mute yourself because your unwanted voice are no. And rate equal to del B upon del T. It means here it will be the positive because the concentration of product is increases and concentration of reactant is decreases. Now, another is reaction rates and stoichiometry. And what do you mean by stoichiometry? Stoichiometry means it is related to balance equation. It is the quantitative relation between the reactant and product. Okay, and just you can see here reactants decreases and product increases, in which, okay, the minus sign again taken the minus sign, and A is the number of moles of reactant A. Small a represent the number of moles of reactant A. Okay, and it is denoted by the stoichiometry, and it will be the 1 upon A, and in the case of B it will be the 1 upon B, and but in the case of product C and D it will be the plus with the plus sign. Okay, now it is very important part, and it is related to factors affecting reaction rate constant or reaction rate. And just I will discuss one by one I will reaction. And the first factor is temperature. And what is the reason why the temperature affect the rate of reaction? And reason is that when we increase the temperature of the reaction mixture or the reaction, the kinetic energy of the reacting molecule are increases. And if the kinetic energy of the reacting molecule are increases, it means number of collisions between the reacting molecules are also increases. Okay, what is the reason why the temperature, why the rate of reaction increases, why the speed of the reaction increases with the temperature or increasing temperature? And reason is that because the chemical kinetics says the all the reaction is depends on the collisions between the reacting molecules. Okay, have you understood? Am I audible? What is the reason? One student बताएगा. What is the reason why the rate of reaction increases with Increase in temperature.
Kinetic energy of the molecules increases, hence the number of collision between the
Reacting molecules are increases. Okay, because if okay, just I'm giving the example here. Okay, without the temperature, okay, the speed of the reacting molecule, okay, or the collision between the reacting molecule is very less. Okay, but if the temperature increases, it means at higher temperature the collisions between the reacting molecules are increases. The fraction of the collisions will be higher as compared to normal temperature. And it is the principle of the collision theory in which, okay, the collision theory, it is related to collisions between the reacting molecule. Collision theory, just you can see here on the screen, when two chemical react, their molecule have to collide with each other. Okay, this is the collision theory. And another is kinetic theory. So there are two theories of in chemical kinetics, and third will be the transition state theory. And another point is concentration of reactants. How the reaction rate is depends on the concentration of reactant. Okay, and this point can be correlated with the collision theory. Okay, it means if the concentration of reacting molecules is higher, okay, it means the collisions between the reacting molecule will be higher, and because of this reason, the rate of reaction will be higher. It means at high concentration, the rate of reaction will be higher, but at low concentration, the rate of reaction will be less. Okay. So what is the reason why the rate of reaction is depends on the concentration, and rate of reaction is directly proportional to concentration of the reactant, because at higher concentration, the collisions between the reacting molecule will be greater. Okay, will be higher as compared to normal compared to less concentration. Okay. Another is catalyst. And what is the role of catalyst? What do you mean by catalyst? कौन बताएगा? What is catalyst? Catalyst क्या होता है? Then we'll discuss the factors which affect the rate of reaction. How the catalyst can affect the rate of reaction. Student, बताओ. What is catalyst?
speeds up or reduces
What is
the speed
catalyst?
of the
Please, pardon, please repeat again.
catalyst speeds up the reaction or reduces the rate of reaction.
It means catalysts are those substances they can change the rate of reaction but doesn't participate in the reaction. Okay, it means catalyst may be positive, catalyst may be negative. But in chemical kinetics, generally I will discuss about the positive catalysts. Okay, it means they can enhance the rate of reaction if you are taking the catalyst in the reaction. Okay, and some of the reactions are takes place in the presence of catalyst. Okay, it means those reactions which are takes place in the presence of catalyst, the speed of this type of reaction will be fast. And reason is that catalyst can decrease the activation energy. Activation energy means it is the minimum amount of energy which is required to convert reactant into the product. Okay, so minimum amount of energy which is called the activation energy, and catalyst can decrease the value of activation energy. Because of this reason, catalyst can speed up the reaction. Okay, what is the reason? Because in the presence of catalyst, the activation energy decreases. And another is surface area of a solid reactant. More area for reactant to be in contact. Okay. And just please tell me if the reacting molecule is a solid, Just time compare here. If the reacting molecule A is the solid, okay, and same reacting molecule A is in powder form, then please tell me speed of the reaction. Regarding I am talking about the speed of the reaction. Okay, which reacting molecule or for which reacting molecule, it means solid and powder in the powder form. Please tell me the speed of the reaction, rate of the reaction. What will be the rate of reaction? It will be the fast or slow in the case of solid or in the case of powder form?
It will be fast in case of powder.
Okay, very nice. Okay, and what is the reason?
Surface area for the reaction increases.
Surface area of the reacting particles, surface area of the reactant increases. Okay, and because of this reason, you know about the nanomaterials. Just this is the example. Okay, in which nanomaterials are solid, no problem. But the size of the nanoparticle is around, it is 1 to 100 nanometer or in between 1 to 100 nanometer. Okay, it is very less size. It means in the powder form, okay, the rate of reaction will be very fast as compared to in the solid form. Because it provided the surface area for the reacting, okay, for the reaction actually. Or because of this reason, if we are taking the reaction, if we are taking the reactant in powder form, okay, it means the collision between the reacting particle will be higher as compared to normal condition, normal state. Okay. Another is pressure of gaseous reactant or product, and just the surface area of solid reactant. Okay, just you can see here the diagram actually. It is the wool. Okay, and in conical flask, this is in the generally solid, but in the normal, when it is just a needle type, okay, the reaction will be fast as compared to these. And another is pressure of gaseous reactant or product. And in this case, actually, this is related to gaseous reactant actually. So many reactions, reaction takes place in the solid state, reaction takes place in the liquid state, or reaction takes place in the gaseous state. So another fifth point, it is related to pressure of the gas. Okay, it means if we increase the pressure, of the reaction mixture, okay, or reacting molecule, it means the gap, okay, the gap between the reacting molecule decreases, and due to this reason, the collisions between the reacting molecules are increases, and the rate of reaction will be fast. Okay, but it is for only the gaseous reactant or product, not for solid or liquid actually. Pressure is related to only the gaseous reaction. Now, another is examples of reaction rate. Okay, and just you can say here, example is actually a graph is plotted between the concentration of chlorobutane, and when chlorobutane is react with the water, okay, it form the butanol. This is the example of the butanol. Okay, the name of this compound is butanol and HCl. Okay, and now here you can see this is the first order. This is example of first order reaction in which the concentration, initial concentration of chlorobutane is 0.100, okay, mole per liter. But after some time, okay, after 600 seconds, just you can see here the graph is decreases. It means the line, okay, just the concentration is decreases with the time, and the concentration of chlorobutane, okay, instead after the 600 second, the concentration of chlorobutane is 0.040 more. Okay, and again, if I see here 0.020, okay, with the time. Okay, so this is represent the rate of reaction or reaction rate, and in which you can see here the equation, change in concentration of A upon T, or with this, if I write the differentiate equation, okay, D, and that is D and concentration upon dt. So the slope of line tangent to curve at any point is the instantaneous rate. Actually, it represents the instantaneous rate of reaction actually. Another is, just you can see here, it is same related to this. Now, reaction rate law and concentration and rate. Another topic of this unit, and it is related to this unit of concept of the chemical kinetics actually, and each reaction has its own equation that expresses its rate as a function of the concentration. Okay, involve the reactant, product, catalyst, so many. Okay, This is called is the rate law. You know, in 11th class, you have studied the rate law. And what is rate law? Just I am giving the example here actually, and it is related to rate law. Just please wait. Yes. Now, in general reaction, okay, the rate of reaction increases as concentration increases since there are more collisions occurring between the reactant. Just I have discussed. Concentration is directly proportional, rate is directly proportional to concentration of the reactant, and it is related to rate law actually. Overall concentration of the depends of reaction rate is given in a rate law. Okay, rate expression in 11th class. Okay, for reaction flow simple rate law, where V is the related to rate law actually V equal to K and concentration of A and concentration of B, and small m and small n is the represent, or it is written on the power of the concentration A and power of the concentration B. Okay, where you can see here m and n, this is the, it is exponents and it is related to order of reaction. Okay, it means if the concentration of A is small a and the concentration of B is small b, okay, but in the form of the order reaction, or what is the definition of order of reaction? Order of reaction means rate of reaction is depends on which or the molecule on which the rate is depend actually. Concentration of reactants on which the reaction is depend. That is, it is related to reaction order. Hello, hello. आपके इधर से आवाज. Hello.
Yes, sir.
Yes, yes. Am I audible?
Yes, sir, you are audible.
Actually, हाँ ऐसा लग रहा है कि yes. So m and n is represent the exponent. Okay, and with respect to specific reaction, the K is the rate constant, and overall reaction order, that is the, it is the sum of the order, that is the m plus n. This is the order actually. It is actually number of moles of A and B is different, but if the reaction is started, if suppose the total concentration of capital A, that is the concentration of A is 100 mole per liter. It means the total concentration of capital A is 100 mole per liter. Okay, and B is again 100 mole per liter. But when the reaction is started, okay, the 100 molecules of the reactant A and the 100 molecules of the reactant B is not participated in the reaction. Only those molecules are participated in the reaction which have a definite amount of energy, which is known as activation energy. It means reaction is only depends on those reacting molecules, okay, which are taking part in the chemical reaction and which are responsible for the reaction. And these represent the order. And if the 100 molecule of A and 100 molecule of B and participating only the 80 and 80, it means small m and small n is related to 80 and 80. Okay, it means the order will be the total sum of the power of the concentration, and sum of the power of the concentration, that is the order will be m plus n. Okay, have you understood? Order will be m plus n. Now, determination of rate law. How we can determine the rate law? And just you can see here the example. And in this example actually, here fluorine, okay, in the stoichiometric coefficient, okay, fluorine and fluorite ion are react together to form 2 FClO2. Okay, this is the product in which just you can see here reaction rate law V equal to K F2 and ClO2 1. Okay, what is the reason why I am writing here? Yeah, why the power of ClO2 is 1? Who will explain why the power of ClO2 is 1? But in the reaction, okay, in the reacting condition or in the left side, you can see here the 2 ClO2. I write the 2 ClO2, but what is the reason the power is 1? कौन बताएगा स्टूडेंट्स? What is the reason?
Because order of reactant is independent of the stoichiometric coefficient. It is experimentally determined, not you cannot determine it physically.
Okay, yes, yes, you are right. Okay, it is not related to stoichiometric coefficient. That is the value of quantitative. Okay, quantitatively it is not depend on the stoichiometry. Okay, it means only the reaction and the rate law V equal to K F2, and it is related to concentration of fluorine and it is related to concentration of chlorate. Okay, good. Another example of expression of rate law, and you can see the another example of expression of rate law here. Elementary reaction, what do you mean by unimolecular reaction and bimolecular reaction? Unimolecular reaction, it means if the only a single reactive molecule is participated in the reaction, it is unimolecular reaction, and bimolecular reaction, it means if the two reactive molecules are participated in the reaction, it is called the bimolecular reaction. Okay, and so you know about the molecularity of the reaction. What is the definition of molecularity of the reaction? It means reactive molecules, that is the atoms, ions or molecules which are taking part in the chemical reactions. It is called the molecularity of the reaction. And now another is simple examples. Just I am giving the and what about the simple examples? Order of reaction. And reaction can be classified into different categories on the basis of order, and just I have discussed the order. Order means reaction is only depend on the molecule, okay, which are taking part in the chemical reactions. Okay, now order and the zero order, it means what will be the definition of zero order? It means rate is not depend on the concentration of the reactant. Rate is not depend on the concentration of the reactant, or rate is independent on the concentration of the reactant. It is the definition of zero order reaction. In the first order reaction, what will be the definition of first order reaction? A reaction is first order if doubling the concentration cause the rate to double. But what is the definition? First order means this is the common definition for zero, first, second. Only a small change in the definition, and it will be, okay, just listen to about the zero order reaction. If the reaction is independent of the concentration of the reactant, it means order will be zero. Or another definition, if the reaction is depend on the zero power of the concentration of the reactant, it means concentration will be zero. Okay, here. And if you want to define the definition of first order, okay, if you want to define first order reaction, it means if the rate of reaction is depends on the concentration of the reactant, or if the rate of reaction is directly proportional to the concentration of the reactant or first power of the concentration of the reactant, it means it will be the first order reaction. And in the case of second order reaction की definition कौन बताएगा स्टूडेंट? देखिए जीरो और फर्स्ट के अकॉर्डिंग आप सेकंड ऑर्डर की डेफिनेशन बोल सकते हैं. Can you speak? Can you tell me about the definition of second order?
Rate of reaction is proportional to the second power of the reactant.
हाँ, second power of the concentration of the reactant. You know, concentration is important. Second power of the concentration of the reactant. It will be the definition of the second order. You are right. Okay, now. So, some of the mathematical equation here and the reaction. If the reaction is zero order, just you can see this is the value of K, differential form, and it will be the A, concentration of A equal to A0 minus KT. It means here, what will be the final conclusion of this? And you know, already studied in class 12th, I hope. Okay, and the first, if the zero, it means K is not K, rate of reaction, rate constant is not depend on the initial concentration of the reactant. It means the value of K will be K equal to X by T. This is the last form of the derivation. And if the reaction is first order, in this case, the rate of reaction or K is depend on the concentration of the reactant. It means what will be the last or what will be the final conclusion, what will be the final value of the K for first order reaction? K equal to 2.303 upon T log A upon, okay, A minus B. This is the final, actually. It is not just, you cannot see here, okay, but it is related to final, the K value for first order reaction, K value for zero order reaction, K value for second order reaction, okay. And here see, some of the mathematical form of the zero, first, second, and second, another is, okay. Now in zero order reaction, the value of K is K equal to x by T. And you can see here the graph, and graph is plotted between the concentration, initial concentration with time and time, okay, concentration and time actually. And you can see this is the straight line in the zero order reaction. In first order reaction, the value of K will be the K equal to 2.303 upon T log A upon A minus X. Another is, what is the unit? And I will discuss about the unit. Just another graph. It is plotted between the, again, the concentration and time. And what will be the example of first order reaction? An example is methyl isocyanide, methyl cyanide, and methyl isonitrile and methyl acetonitrile, actually another name of these reacting or product, reacting molecular product is. And this is the example of first order process. And you can see here again the initial concentration, suppose the initial concentration of 160 mole per liter, but time, okay, with the time the concentration is decreases, okay, and it is around 20 mole per liter, but 30,000 second, after 30,000 second, okay, and thus the rate equal to K CH3NC, that is, it is depends on the concentration of acetonitrile or methyl isocyanide for all time intervals, okay. Reaction is takes place on the 198.9 degrees centigrade. And the first order process, just you can see here, log AT equal to minus KT plus log A0. A0, what is the A0? A0 is the it is indicate the initial concentration of the reactant, and AT is the after T time the concentration of the reactant actually. And another graph you can see here. But time is so less, so just second order, in the second order reaction, just you can see it is different from the first order reaction actually. It is plotted between the initial concentration, that is the 1 upon concentration initial after concentration of reactant after T, okay, versus time. But in first order the graph is plotted between the concentration of after T time and time, but in the case of second order reaction, second order process, you can see here the graph is plotted between the 1 upon concentration of hello.
Yes, sir.
हाँ, मैम एक्चुअली मुझे बताइए अभी कितना टाइम तक मैं थोड़ा सा फास्ट फिनिश करूं. And you can see here the half-life time. And half-life time means, what is the definition of half-life time? Is the time taken for the concentration of reactant to drop to half its original value. That is, if the initial concentration of reactant is 100 mole per liter, okay, and it decompose, it consumes about up to 50 mole per liter, that is the time which is required for the consumption of half concentration of the reactant, okay, which is known as half-life time. And half-life time for zero order reaction, the value is A0 upon 2K. Half-life time for first order reaction will be the T half equal to log 2 upon K, and second order reaction it will be the T half equal to 1 upon Ka, and the initial concentration of reactant, okay, in which T half is represent the half-life time actually. Just you can see here T half, that is the, it is, and the half-life can be denoted by the T half actually. And with the, in this graph you can see here, if the initial concentration is 150, then it is remaining okay, but after the consumption, after the 10,000 second, okay, the it is decomposed half, that is the value is 75. 150, it means the half value, and then again the half value of 75 is 37.5. Okay, it means after 30,000 seconds, this is the half-life for 75 mole per liter, and the value of 75, it is the half-life for 150 mole per liter. Okay. Now, again, you can see here the diagram, okay, in which you can see here, this is the particle of the concentration, particle of the reactant A. Okay, suppose this is the 16 particle here, but you can see here 8 particle, or I don't actually I can't count it, but it is related to half-life time. Okay, suppose this is the 20, and that will be the 10, that will be the 5, and that will be the 2.5 here actually. Okay, but this represents the half-life time of the reaction actually. Half-life time for first order, and the value of half-life time for first order 0.693 upon K. Okay, and this value is actually how we can obtain this value, and it can be obtained from the K value of the first order reaction, and the K value for first order reaction is K equal to 2.303 upon T log A upon A minus X, in which if we will put the value of half-life, that is the initial concentration of reactant A is A mole per liter, small a mole per liter, but after half-life time it will be A by 2 actually. A by 2, that is, it is the half concentration of the reactant A mole per liter. Okay, and when we put the value of this A upon A minus X, okay, instead of A minus X, I will put the value of A by 2. Okay, I will get here the value, and when I multiply 2.303, that is the final value of half-life time for first order will be 0.693 upon K. Okay, this is the value for half-life time for first order reaction, and it will be the 0.693 upon K. Okay, and this is the question, this is the problem actually, and this is the numerical problem related to half-life time for first order reaction here. And what is the half-life of nitrogen pentoxide if it decomposes with a rate constant of 5.7 into 10 to the power minus 4 second inverse? Okay, and if we put the value of N2O5, that is the value of K, in the equation, in the half-life equation for first order reaction, T half equal to log 2, that is the value of log 2. When we put the value of log 2, 0.3010, okay, in the first order reaction, or the value of first order reaction mathematical derivation, okay, we will get here the 0.693, and upon the value of K is given in the numerical, and the value of K is given in the numerical is 5.7 into 10 to the power minus 4. Okay, it means the answer of this reaction will be 1200 seconds. That is the 20 minutes. It means the N2O5 is decomposed half in the time is 20 minutes. It means in 20 minutes it will decompose half of its initial concentration. And another is how you can identify the reaction is actually question is saying about asking about the reaction is first order, reaction is zero order, reaction is second order. And how you can understand? कौन बताएगा स्टूडेंट? आप कैसे बताओगे इस क्वेश्चन में, कैसे बताओगे कि आपसे फर्स्ट ऑर्डर से के रिगार्डिंग क्वेश्चन किया है या जीरो ऑर्डर के रिगार्डिंग क्वेश्चन किया है? हाफ लाइफ टाइम किसके बारे में पूछ रहा है ना?
By seeing the unit of rate constant.
हाँ, यस प्लीज पार्डन, आप रिपीट करेंगे एक बार?
By seeing the unit of rate constant.
हाँ, okay, you are right. Actually, just you can see here the unit of rate constant, है ना? Actually, the unit of rate constant for different order is different. For zero order is different. For first order is different. And the first order, the unit of rate constant is second inverse. Because if we want to determine, we want to find out, or we want to calculate the unit for rate constant for zero order, it means we have to put the value of concentration, and the value of concentration is moles per liter. Okay, moles per liter, and time will be in the second actually. Okay, second, minute. Okay. It means if the question will be in the minute, that is the minute inverse, that is the second inverse, that is the hour inverse. Okay, but in this case you can see here the unit of K for first order reaction is second inverse. It means it is related to first order. And another, this is same again. Just you can see this is the 16 particle here. This is the 8 particle. Okay, this is the 4 and this is the 2. Okay, and each of the concentration actually here A0 by 2, A0 by 4 and A0 by 8. Okay, it is indicate the half-life time of each cycle actually. The first cycle is A0 by 2, second cycle is A0 by 4, third cycle is A0 by 8, and last is, okay, the third is A0 by 8 actually, and last will be the 0 actually. No. Half-life time for second order, just you can see here the half-life time for second order, because I will not take much time of you. Actually, it is 11 o'clock and in 12 o'clock it will be again my lecture. No? So now, equations and reaction mechanism. What will be the mechanism? Mechanism means it is the elementary step of the reaction actually. Just I am giving the example, simple example to here to explain the reaction mechanism. And example is here, just if you go for college, if you go for college from your house, okay, just you out of the home, okay, and you reach to the bus stop. Okay, if suppose you reach college in 1 hour from your home, okay, you will reach your college in 1 hour from your home. It means that overall rate is 1 hour. Okay, now suppose you out from your house, it means reaction is started. You will reach at the bus stop. You will go into the bus. Okay, then bus is started. Then bus will be the stop will be stopped in other stop. Then again stopped in other stop. It means, and it will take 1 hour to reach from the bus stop to your college. Okay, it means in this time you can see steps that is the overall is 1 hour, that is the rate of reaction, rate or speed of the reaction is 1 hour. Okay, but the different steps was taken by you or was taken by your bus. This is the mechanism of the reaction. Okay, it means what will be the mechanism? Mechanism means the sequence of elementary step that leads to product formation is the reaction mechanism. Okay, it is the reaction mechanism. Just you can see here the 2NO plus O2 form 2NO2. But what will be the reaction mechanism? Reaction mechanism will 2NO, that is the 2 molecule of NO. Okay, these two molecule of NO form N2O2, and these N2O2, okay, elementary step is this N2O2 actually, just you can see here. Again, N2O2 plus O2 react to NO2. Okay, it means the final product in this reaction 2NO plus O2 form 2NO2. But the step is that elementary step NO plus NO. It means NO and NO react together before they react with oxygen to form N2O2. And then N2O2 is react with O2 to form 2NO2 actually. So this is the step. Okay, and this is the mechanism of the reaction. And you can see here the overall actually in which the some entities will be the neglected actually, and the final reaction will be 2NO plus O2, it will be 2NO2 actually. And rate law determining step, just you can see here the rate law for the determining step, that is the slowest step, which will be the rate determining step actually. Slowest step of the reaction will be the rate determining step. And another is reaction mechanism. It is related to reaction mechanism. Okay, so no problem. Again, a unimolecular, bimolecular, trimolecular reaction. And please tell me, actually my question is that this type of molecular reaction can be considered in the chemical kinetics. Who will speak? Unimolecular, bimolecular, thermomolecular, that is the tetramer. Okay, but you explain. Okay, bimolecular terminal. It means in chemical kinetics, this type of reaction can be considered in chemical kinetics: unimolecular, bimolecular, or trimolecular. But tetramolecular reactions or pentamolecular reactions cannot be considered in chemical kinetics. What is the reason? Only unimolecular, bimolecular, and trimolecular reactions or speed of the reaction can be considered in the chemical kinetics. What is the reason? And reason is that because in chemical kinetics, you know about the rate of reaction, it depends on the collision. And chemical kinetics said that only in a single time, only the reacting molecule can collide by the 3 directions. That is not possible to collide by 4th or 5th direction actually. It means in chemical kinetics, only unimolecular, bimolecular, and trimolecular reaction of the considered actually. And another is, just you can see here the another unimolecular, what will be the elementary step and what will be the rate law. So reaction intermediate, and what will be the, just I have discussed this, so no problem. And multi-step mechanism, just you can see here the plaza, that is the cars load at plaza. Okay, first, okay, that is the step 1, 2, and 3. This is the rate determining step of the reaction actually, and which is related to mechanism, multi-step mechanism, or multi-step synthesis. In organic synthesis, you have listened about the multi-step synthesis. Just you can see here, this is the car. First, when it is started, is go to the another cross load at the plaza A and plaza B. Okay, and just you can see here with the time, okay, the speed will be the slowed actually. That is the overall reaction cannot occur faster than this slowest rate determining step. It is represent the rate determining step. And you know what about the activation energy, which is very important part of this unit actually, activation energy. And only I will discuss about the activation energy, then we'll finish it. Okay, and not what do you mean by activation energy? Energy which is required, minimum amount of energy which is required for a reaction. And just you can see here, this girl is stand here. And if she want to go out of the hill, what should have, what type of energy she is required actually? What type of energy she is required? Who will speak? Suppose this is the reacting molecule actually. And this reacting molecule want to convert it into the product, want to cross the hill, that is hill. This is the amount of energy, and this is the value of activation energy. It means she cannot cross the hill without the energy actually. She has some of the energy, she has required some of the energy, which is known as activation energy. And without activation energy, she cannot cross the hill. Okay, and she cannot catch this type of flag actually. Okay, she has to cross this hill actually, and this is the activation energy. Just as a ball cannot get over a hill if it does not roll up the hill with enough energy. A reaction cannot occur unless the molecule possesses sufficient energy to get over the activation energy barrier. This is the energy barrier actually. And just you can see here the graph actually. And graph is just, I'm going to on the graph, and graph will be the related, this is the example. Just, okay, yeah. You can see here the A plus B. This is the reacting molecule form the C plus D. And in the case of exothermic reaction, it is the energy is released. A plus B is form the activated complex when it get the activation energy, and form the C plus D, that is the product. And the energy will be the product will be the less. Okay, and the energy of the reacting molecule will be the higher because the reaction is exothermic. But in the case of endothermic reaction, C plus D, okay, and A plus B. In the case of endothermic reaction, A and B gain the energy. Okay, and when gain the energy, okay, it form the activated complex by gaining the activation energy, and then form the C plus D. But you can see here the energy of C plus D is higher because it absorbs the energy. Okay, reacting molecule has absorbed the energy. But here the reacting molecule lose their energy. Because of this reason, the energy of C plus D will be less, and the energy of but in the case, the energy of C plus D will be higher. This is the energy diagram actually. And another is Arrhenius equation, but so I have taken the so many time. So, and again around 12 o'clock my lecture in another. Okay, so I will discuss another way. So Arrhenius equation, just this is the last topic, Arrhenius equation, and it is related to temperature actually. How the rate constant is depends on the temperature actually. And just you can see this is the Arrhenius equation. Log K equal to minus E upon RT plus log A, where E is the activation energy, R is the gas constant, and T is the absolute temperature. And from these equations, we can determine the activation energy if we know about the value of K, if we know about the value of R, and if we know about the value of absolute temperature. Okay, we can calculate the activation energy. Now, okay, dear students, thank you very much for your kind support. And so many topics have been left, but sorry, in another lecture. Thank you. So, thank you very much for your kind attention. Thank you.
Thank you, sir.
Sorry, ma'am. Actually,
Thank you very much for this informative session. And definitely, chemistry should not only be a science and profession, but also an art. Now, from student side, if you have any question to ask,
yes.
You may ask.
Sorry, बहुत सारे टॉपिक छूट गए हैं, लेकिन so it is less. I have no time actually. At 12 o'clock actually my lecture in another session.
Yes, sir. Yes.
Sorry.
Okay, sir, हम next time ले सकते हैं आगे का.
हाँ, वो थोड़ा सा क्या हो रहा है ना कि time actually chemical kinetics वैसे भी it will take around 10 lecture. No, so it is not possible to complete in one lecture actually. So many topics have been left.
Yes, student में से कोई question पूछना चाहते हैं?
हाँ.
सर मुझे क्वेश्चन पूछना था.
हाँ, yes ma'am, yes.
सर जो ऑर्डर है रिएक्शन की अगर फ्रैक्शन में हो, मतलब फर्स्ट और सेकंड ऑर्डर के बीच हो, अगर फ्रैक्शन में भी होती है ऑर्डर तो
हाँ, yes.
हम उसका रेट कांस्टेंट क्या लिखेंगे सर? मतलब रेट कांस्टेंट क्या होगा?
Yes. So actually we can write here but it will actually it will around the, suppose the rate of reaction is the value of K is 0.8, suppose. Okay, it is near about 1, so it will be considered in first order actually. Okay, and if it is the value of K is 0.5 above, suppose that, okay, then we can represent the value of K will be the 0.5. That will be the order actually. Order may be in fraction also.
Okay.
So it is depends on the value of K actually.
Okay, sir. Thank you so much.
Thank you.
Good morning, sir. It's okay now?
Yes, okay.
Okay.
Sorry, sir. Actually, मेरा complete नहीं हो पाया, लेकिन sorry, sir. Actually.
No, sir. Okay, it's okay.
Okay, thank you, sir. Now I invite Ms. Nehal Pachare to propose a vote of thanks.
A very good morning to all of one. I am Nehal Pachare. On behalf of Department of Chemistry, deem it a great honor and privilege to propose the vote of thanks on the today's session. Let me first of all start giving a glory to the Almighty God for making this session successful. I owe my special thanks to Honorable Dr. Suhasini Vanzari ma'am, President, Amar Seva Mandal, Nagpur, Honorable Advocate Abhijit Vanzari sir, MLC and Secretary of Amar Seva Mandal, Nagpur, and Honorable Dr. Smita Vanzari ma'am, Treasurer of Amar Seva Mandal, Nagpur, for their continuous support and guidance. I also extend my special thanks to Dr. Dilip Badwait sir, Principal of Kamla Nehru Mahavidyalaya, Nagpur, for his valuable support and guidance. I express my special thanks to our today's guest, Dr. Vijendra Singh, Assistant Professor,
Thank you, madam. Thank you
Department
very
of
much.
Chemistry, School of Liberal Arts and Science, Modi University of Science and Technology, Rajasthan, who despite his busy schedule has found time to grace this today's session and give the information about the chemical kinetics. And I also express my heartfelt thanks to Dr. Mrs. Sunita Gadegone ma'am, Department of Chemistry, Dr. W.B. Gunule sir, and Dr. M.S. Wagh ma'am, Kamla Nehru Mahavidyalaya Nagpur for their enormous and logistic support and their guidance. I also thank to the faculty members Dr. Rashmi Dubey ma'am and Mrs. Swati Burde for their valuable support. Last but not the least, I also extend my thanks to all the students for their cooperative participation for making this session successful. Thank you, sir.
Thank you. Thank you very much.
Thank you, sir. Sir,
Thank
we are taking one group photograph. So all the participant students switch on their video camera. Make the video on. Hello. Make the video on, students.
स्टूडेंट्स सभी आप अपना वीडियो ऑन कर दीजिए.
Okay, madam. Sir, thank you.
थैंक यू.
Okay, thank you very much, sir.
Yes, thank you,
Sorry,
sir.
पर लेकिन थोड़ा complete नहीं हो पाया.
नहीं अभी वो कैसा वास्ट है ना?
Yes, yes, yes.
Okay, sir. Okay, thank you.
Thank you very much. Thank you.
Yes, sir. Yes, 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 yes.